Have you ever noticed how ice turns into water and then disappears as steam when heated? I know all of you must have seen this process. Is it magic or science? Welcome class 8 students to the second video of matter. Now matter exists in three main states. You have already studied this in your lower classes. And what are those three states? The three states of matter are solid, liquid and gas. Okay, solid, liquid and gas. And we know that solid, we have the example of ice. It melts at 0 degrees Celsius temperature to form liquid, and at 100 degrees Celsius temperature it changes into gas. Under certain conditions, matter can change from one state to another, and this process is called the change of state of matter. Now coming to the next part, that is interconversion of matter. Now here you can see clearly that the solid is changing into liquid state and the liquid into gaseous state. Now there are certain terms which are involved in interconversion of matter. Now firstly, seeing solid changing into liquid state, that is conversion of solid into liquid will take place on heating, and the process will be called as melting. Now remember that these things will take place under conditions when there is a change in temperature and pressure. Okay. So solid changing into liquid state, the process is called melting. Liquid state changing into gaseous state on heating is called vaporization. Again, if gaseous state has to change back into liquid state, the process will be called liquefaction, or we can also say it is also called as condensation. And liquid state changing back into solid state, it is called solidification. Or what is the other term? What is the other term for solidification? It will be freezing. Okay, so solidification, or we call it as freezing. Then solid state directly changing into gaseous state, the process is called sublimation, or the gas changing into solid without changing into liquid state. Okay, the process is called sublimation. Example you can remember is of naphthalene. It sublimes at room temperature. Okay, so these are the terms. The diagram is important and you should be aware of what these terms, what is the meaning of the terms, that is melting, vaporization, liquefaction, solidification and sublimation. Next, you have to understand the change of state of matter on the basis of kinetic theory. So interconversion of matter on the basis of kinetic theory is something which you need to understand in grade 8. So three aspects you need to keep in mind whenever you're talking about the change in state. Firstly, we are talking about melting. So three aspects are particles, interparticle space and interparticle attraction, which we had earlier discussed in our first video. That is what were the postulates of the kinetic theory of matter. So here in melting, what will happen? Temperature will rise or decrease. Just think for a moment. Yes, the temperature is going to increase. And because the temperature is going to increase, the particles will gain energy. Now in solid state, you can see that the particles are closely packed. And when they are gaining energy, this energy will be stored in the form of potential energy. And this stored potential energy will increase the interparticle space. Because of which, what will happen? The interparticle attraction is going to decrease, and at melting point, what will happen? The particles will become free and the solid state will change into liquid state. That is what is happening, solid changing into liquid state. Next, coming to vaporization, again on the basis of three aspects. Again, what will happen? How liquid will change into gaseous state? Will the temperature increase or decrease? Think for a moment. Yes, definitely the temperature has to increase. When there is a change from liquid to gaseous state, the temperature has to increase. Again, due to increase in temperature, the particles will gain energy. The stored potential energy will increase the interparticle space, because of which the interparticle attraction is going to decrease. And at boiling point, that will be a fixed temperature. When we talk about boiling point and melting point, these are fixed temperature at which the conversion is taking place. For example, when I am talking about melting point, it is the fixed temperature at which solid changes into liquid state, ice changing into water. And what is the boiling point? Again, it is a fixed temperature at which the liquid state changes into gaseous state, and we know that the boiling point of water is 100 degrees Celsius. So here also at boiling point, the particles will become free, and what will happen? The liquid state will change into gaseous state. So whenever you are explaining the change of state of matter on the basis of kinetic theory, please consider these three headings. Then only you will be able to explain that how this process is taking place. And obviously, based on this, you will get application based questions where you have to think and then answer. Okay, moving to the next process or the next interconversion, that is liquefaction. Now liquefaction, what is happening? The gas is changing into liquid. Again, considering the three aspects, that is particles and interparticle space. Now think and tell me, in liquefaction, will the temperature increase or decrease? Now see here what is happening. Gas is changing into liquid state. So here temperature is going to decrease or temperature will fall. And because the temperature will fall, the particles will lose energy. And when they are losing the energy, the potential energy will also be released as heat energy. Okay. So when the potential energy is released as heat energy, what will happen? The released potential energy will decrease the space. So what is going to decrease? The interparticle space is going to decrease, because of which what is going to increase? The interparticle attraction is going to increase. So at liquefaction point, what will happen? Or at liquefaction, what is going to happen? The the particles will slow down. Particles will slow down. You can see in the gaseous state how randomly the particles are moving. In liquid state, the particles are going to slow down. And what is going to happen? The gas molecules will change into the liquid state. Okay, the gaseous state will change into the liquid state. Lastly, coming to solidification. Again, think and answer. Here what is happening? The liquid state is changing into the solid state. So will there be increase in temperature or decrease? Definitely the temperature is going to fall or the temperature is going to decrease. Again, what will happen? The particles will lose energy. The stored potential energy will be released as heat energy, and the interparticle space is going to decrease. Okay. The stored potential energy will be released as heat energy. Okay, so here what is happening? The particles are losing energy and the stored potential energy is releasing the heat energy, because of which the interparticle space decreases and the interparticle attraction increases. So what will happen at solidification point? At solidification point, at solidification point, the particles will slow down. Okay, they are coming closer to each other, because of which the particles slow down and the liquid state is going to change into the solid state. Okay, so these are the four processes which we have seen on the basis of the kinetic theory of matter. Now lastly we are going to see the law of conservation of mass. Now Lavoisier was the scientist who formulated the law on the results of an experimental evidence which was carried out in this H-shaped tube. So let's first see what the law states. It states whenever a chemical change takes place, the total mass of the reacting substance is exactly equal to the total mass of the products. Or in simple words, we always say that matter can neither be created nor destroyed during a chemical reaction. So Landau took this H-shaped tube and he took two chemicals in that. In one of the limbs he placed sodium chloride solution, and in the second he placed silver nitrate solution. Okay. Then he introduced the solutions in the limbs of the tube, and then the tube was sealed and it was weighed before the experiment. Okay, the solutions were weighed, the tube was sealed, and then the whole solution, both the solutions were mixed thoroughly by shaking. So when sodium chloride, let's see what happens when sodium chloride reacts with silver nitrate. We get sodium nitrate and we get a white precipitate of silver chloride. So after the experiment also the tube was weighed again and it was found that the total mass of the reactants is equal to the total mass of the products. So that was the result, that the total mass of the reactants was equal to the total mass of the products. So by this experiment he proved that matter can neither be created nor destroyed. So who formulated the law? Please remember the name of the scientist. It was Lavoisier. Lavoisier has formulated the law. He formulated the law and the experiment was conducted by Landau. He used this H-shaped tube. This was the H-shaped tube which was used to conduct the experiment. Now there are certain limitations of the law which we can understand in this way, that the chemical energy that was stored in the reactants is released in the form of heat or light energy. So hence mass is getting converted into what? It is getting converted to energy. Okay, so what is actually happening? There is a change in the form of matter, but there is the law as it states that matter, that atoms can neither be created nor destroyed. So matter can neither be created nor destroyed, but there is a change from one form to another. Hence what was the conclusion? That the total mass of the reactant substance is equal to the total mass of the product. So that sums up the lesson of matter. We will be discussing few important questions, specifically the application based questions, so that you know how you will be getting questions from this lesson. So please go through the chapter. Reading of the lesson is very important. Learn the definitions and always stick to the language of your textbook, children. Never make your own definitions. Whatever definitions are given in the textbook, please learn them as it is given. That will help you to fetch good marks in your examination. So we'll discuss the important questions in the next video of matter. Thank you students, and see you in the next video.